Hello, this is David Wales. Sorry about my first video, audio cut out, so I'm just making another one. So my first one is easy. I'll do breadth first. It reports the statistics. Then I can say yes to print out the path from the answer to the node. I can do medium. I can do a star search with the heuristic being tiles out of place. There we go. I'll say node bringing up the board. We'll do hard depth first. There we go. Hard greedy. And then we'll do hard with the A star search with the Manhattan blocks heuristic. Okay. And then user can enter their own board if they choose. So the one I entered was unsolvable, so I'll exit the software. User interface is all inside the main. It wasn't a very complicated thing, so I figured why not? There wasn't anything else in the main. So it's just whiles and switch cases and checks for invalid inputs, and it's not a very complicated system. Board.h, I used a vector of ints to keep track of the board, and then it had the ability to print its own board. It had the big three. It could clear its current board, or it can make the easy board, medium board, hard board, or the user can enter their own board. It had a function to return where the blank tile was, the index. It had a function to return the Manhattan distance of the board, in this case the number of misplaced tiles on the board, and then it could also turn the board into a string, so it just took the string equivalent of it, then obviously the check answer and make move. So for this, it's just a bunch of copying. It's not too difficult, pretty straightforward. Place tiles, just all pretty small stuff. And then for my searches, I had a node struct, which just kept all the relevant information for the nodes, so depth, children, parent, my board, 0 index, Manhattan distance, and F. I had a operator, a bool operator in the comp struct so that I could use a priority queue, which I'll tell later on. I had a function that could report repeats, print path from the answer to the node, or answer to the root, print report, print the statistics. I had all of my searches in one class, unfortunately. By the time I realized I shouldn't do that, I was already pretty far, and I just commented a lot to try to make up for it. Clear repeats, and then a function that finds successors. And then I use an unordered map to keep track of repeats. I just took the string as a key, which I said earlier, with my string equivalent in my board.h, and then it stores the node. And the rest are just keeping track of stuff. So in here, in my .cpp, here's the successors. It just finds the successor and then puts it inside the parent's child vector. Repeat just finds if it's a repeat or not. Print path, print report. My breadth first search and my depth first search were pretty similar, so I'll explain one. Basically, I made a DQ, and it just pushed the root onto the repeat tracker and onto the queue. And then while queue wasn't empty, it just keeps on going and pops the first node, and then it checks if it's an answer. If it wasn't, it checks the successors, puts them in the node's children, and then it goes through the node's children, sees if they were repeats. If they weren't, puts them in the tracker, pushes onto the queue, and then so on and so forth. Now the difference is just push back versus push run. Yeah, not very hard. Now greedy best first search. Similar thing, just priority queue instead of DQ. And then for putting on the queue, I just took the F. I took the F for greedy, so I could use the same compare stress. It made it really easy for the priority queue. And then it just pushes onto the queue in ascending order. So I would just take the top node off, pop it, see if it's the answer. Same general premise for A star search. It just took the misplaced tiles plus the depth instead of just the Manhattan distance, and then pushes onto queue. And then my other A star was Manhattan distance plus depth, and then pushes down to the queue. So I think that's it. So have a good one.